Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of second derivative. So as per the problem, determine the value of the second derivative at the value indicated. State whether the curve lies above or below the tangent at this point. So the first function is f at x equals 2x cubed minus 10x plus 3 at x equals 2. So we have to determine the value of the second derivative for this function f at x equals 2. So the first step is to find the second derivative of this function. So for that we need to find the first derivative first. So let's start with the first derivative. So prime of f at x equals. Now for the first term, we'll have to use the power rule of derivatives. So 2 is the coefficient of this term, so it will stay as it is. And as per the power rule, for x cubed, we'll move the exponent 3 to the front and subtract 1 from 3. Now in the second term, negative 10 is the coefficient, so it will stay as it is. And the derivative of x is 1. 3 is a constant, so its derivative is equal to 0. Now we can simplify this expression. So 2 times 3 is 6. And then 10 times 1 is 10. So this is the first derivative of the function f at x. Now we can find the second derivative. So we'll have to find the derivative of this first derivative. So double prime of f at x equals. So in the first term, 6 is the coefficient, so it will stay as it is. And as per the power rule, the derivative of x squared is 2x. And 10 is a constant, so its derivative is 0. So we got 2x for x squared using the power rule. So as per the power rule, we move the exponent to the front and we subtract 1 from the exponent. So 2 minus 1 is 1. That's why the exponent of x is 1, but we don't write 1 as an exponent. So now we can simplify this expression. So 6 times 2 is 12, so we get 12x. Now we can find the value of the second derivative by subbing in x as 2 in this equation. So double prime of f at 2 is equal to 12. So we sub in x as 2. Now we can multiply 12 and 2. So double prime of f at 2. So this is the value of the second derivative at x equals 2. So this should be the final answer for the first part. Now in the second part, we have to find whether the curve lies above or below the tangent at this point. Now we got a positive value for the second derivative. That means the curve concaves up. At x equals 2. So that means the curve is above the tangent. So there's a very important concept we need to understand and memorize, that if at a particular x value the curve concaves up, then the curve is above the tangent. So we can write our concluding statement here. So the curve is above the tangent. So we are done with the first function. Now we can analyze the second function. grx equals x squared minus 1 over x at x equals -1. So first we'll have to change this grx function to find the first derivative. So we should move the x in the denominator to the numerator. That will make it easy to find the derivative. So when we move x to the numerator, the exponent on x becomes -1. Now we can find the first derivative of grx. So for the first term, we can use the power rule. So we can move the exponent 2 to the front of the term and then subtract 1 from it. Then minus. For the second term, we can again use power rule. So we should move the exponent to the front and subtract 1 from it. Now we can simplify this expression. Now minus -1 becomes +1. And we don't write 1 as a coefficient. So this is the expression for prime of grx. Now we can find the derivative of this function to find the second derivative. So double prime of grx equals, so for the first term the derivative is just 2. So 2 is the coefficient, so it stays as it is, and the derivative of x is 1. Now for the second term we can use power rule. So we can move the exponent to the front, and now we can subtract 1 from the exponent. Now we can simplify this expression. Plus -2 becomes -2, and the exponent becomes -3. Now we can move the x term to the denominator to make the exponent positive. So this is the expression for the second derivative of grx. Now we can sub in x as -1 in this second derivative. Now we can evaluate this expression. So -1 cube is equal to -1, and 2 over -1 is equal to -2. And minus -2 will become +2, which is equal to 4. So this is the final answer for the first part, the value of the second derivative. Now we have to state where the curve lies above or below the tangent at this point. So again, we find that the second derivative value at x equals -1 is greater than 0. That means at x equals -1, the curve concaves up. So that means the curve is above the tangent. So if the second derivative value is negative, that means the curve concaves down, in that case the curve will be below the tangent. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.